Hello and good morning to everyone. Welcome to our chapter Real Numbers. So, in the last days, we have already done the discussion of the fundamental theorem of arithmetics that everyone knows that any composite number we can express it as the product of the prime factors in a unique way apart from the order of its prime factors. So, now we will do the exercise 1.2. Actually, previously exercise 1.1 it was in our syllabus, but this time because of the COVID spread that the 30% of our course has been reduced. So for which Euclid's divisional algorithm has been excluded from our syllabus. So by using fundamental theorem of arithmetic, we just have to solve the exercise 1.2 all the questions. Everyone knows that the fundamental theorem of arithmetics having the application to find the LCM of two otherwise more than two numbers, also HCF of two numbers otherwise more than two numbers, also to show that the irrationality of any of the number, also we have to take the help of the fundamental theorem of the arithmetics. So let's have an attempt to do the question number 1. In the first question, see everyone, in the first question it is given express each number as the product of the prime factors. Express each number as the product of its prime factors. Everyone knows in the standard 5, also in the standard 6, we know how to do the prime factorization of a number. 140, you know that 140 we can do the prime factorization by doing the repeated division by its prime factors. The number is divisible by 2, you can divide by 2, then after 1 second divisible by 2, then after 1 second divisible by 5, and divisibility by 7. Then after finally here I got that 140 it is equal to 2 into 2 into 5 into 7. Also one can write it in the exponential form. Here 2 it is multiplied for 2 times, for which one can write it as the 2 square into 5 into 7. Just like the first bit I have done the discussion, likewise manner double I question can be done, also third I, IV and also V question also can be done. As in our last days, only we were acquainted to solve the question only by doing the prime factorization. But here something extra we have done by doing the prime factorization in the exponential term only I just wrote. Where I got 2 into 2 twice, so it means instead of writing 2 into 2, I wrote it as the 2 square into rest of the other factors. So I hope question number 1 it is very easy for each and everyone. Now I am showing you how to find the LCM and HCF of two otherwise more than two number by using by using fundamental theorem of arithmetics. First one question it is given that you have to find out the LCM and HCF of the following integers and verify that LCM into HCF it is equal to the product of the two numbers. Remember in standard 6 we knew it that LCM and HCF of a two number it is also same as the product of the two numbers. Here also once again we have to do the same. See here two things it is asked. Actually first it is asked that you have to find out the LCM and HCF of two numbers. This one it is the first thing, and second one it is asked that you just have to verify whether the product of their LCM and HCF is it same as the product of the two numbers or not. So one question I am doing it for you, and I hope the double I and third I question it can be done by you. Okay, so everyone show your attention towards the question number I. See 26, just like the question number 1 prime factorization it was done, question number 2 I, so here it is one number it is 26 and another number it is 91. Actually we can find out the LCM and HCF by first doing the prime factorization. See 26 can be prime factorized as 2 into 13 and 91 can be factorized it as 7 into 13. See To find the HCF, actually HCF says HCF is the product of the common prime factor in both the prime factorization. One prime factorization it is 2 into 13, another prime factorization it is 7 into 13. In both the prime factorization 13 it is common only. So for which HCF it is our 13 only. Then after LCM, LCM is the product of the prime factors used in highest number of times in both the prime factorization. See, actually which prime factors are there in both the prime factorization, we have to write that prime factorization, that number of times which used maximum number of times. See, LCM 2 it is used in the 26 once, but 91 no 2 is there, so for which highest number of 2 is used it is equal to 2, so means single 2, so for which LCM it is equal to 2. Then after 7 is used highest number of times, that is 1, because in the first prime factorization no 7 is there, so for which highest one it is once, so for which I am writing 2 into 7. Then after 13 is used in the first prime factorization once, also in the second prime factorization once, so for which there it is 1, also here it is also 1, so it means highest one it is also 1. So LCM is equal to 2 into 7 into 13, which is equal to 182. It means I got the HCF equal to 13 and LCM is equal to 182. Then after second thing it was asked, actually two things it was asked. First one it was asked that we have to find out the LCM and HCF by using the fundamental theorem of arithmetic. Then after we have to check whether the product of the LCM HCF is it same as the product of the two numbers or not. So let's have the check for the second one. HCF I got 13 and LCM I got it as the 182. Now product of the two numbers you can find it easily by multiplying 26 into 91, and here the answer we got 2366. Then after HCF into LCM it is equal to 13 into 182, it is also same as 2366. So it means one thing it is clear from both the expression that the product of two number it is also same as the product of their LCM and HCF. Another thing, once again I am repeating that this formula it will be applicable only for the two numbers only. HCF of a two number and LCM of a two number it is same as the product of two number, but for three it will not be applicable at any cost. Okay, then after second question also in the same way 510 you can do the prime factorization, 92 also you can do the prime factorization. HCF I have already said only you have to multiply that prime factor which is common. See, in the upper case 2 is once, below 1 2 it is twice, so for which 1 1 2 it is common, 1 2 it is common. Then after 3 it is not common, another 2 it is not common, 5 is not common, 17 it is not common, and 23 it is also not common. So for which HCF it is only 2 it is the common factor between the two prime factorization. Then after LCM means which factors used in highest number of times, that highest number of times I have to write. See, all the factors I have to take. 2 is used, 3 is used, 5 is used, 17 is used, 23 is also used. So first I have to check 2 is used highest number of times in which factorization. Upper one 2 is once, but below one 2 is used twice. So for which twice is the highest one, so for which double 2 I wrote in the LCM. Then after in the upper factorization 3 has been used once, but below one no 3, so for which highest one it is single 3. Single 3 I just wrote in the LCM. Then after 5 used highest number of times once, for which I placed 5 there. 17 used in the upper one once, but below one no 17, so for which highest one it is only 117. And 23 used once, so for which I wrote it as the 23. So here it is the LCM is equal to 23,460. Now first case it was done. In the first situation it was given to find out only the LCM and HCF, and already we obtained the LCM and HCF of two number. Then second one it is our checking, otherwise verification step, where the product of two numbers is equal to 510 into 92, which is equal to 46,920. Again, the right hand side it is HCF and LCM, their product it is also 46,920. So it is clear from both the sides that the product of two number it is same as the product of their HCF and LCM. So third I question in the same way one can do the question number third I. So now we will do the discussion of the question number 3. Previous case we got the LCM and HCF of only two numbers, but in this question number 3 it is given that to find out the LCM and HCF of a three number by using prime factorization. Actually prime factorization it is also one can say we are using the fundamental theorem of arithmetics. Okay, so first number it is 12. See, 12 everyone knows one can factorize it as 2 into 2 into 3. Instead of writing 2 into 2, just see I am showing once again. Instead of writing 2 into 2 into 3, here I have written it as the 2 square into 3. And 15, one can write it as the 3 into 5. 21 one can write its prime factorization 3 into 7. See, here it is the HCF and LCM definition I will say in the another way, because here in this case the prime factorization it is written in the exponential form. Actually both the way which one you prefer to do to find out the LCM and HCF, in that way you can do, but here I am showing you another formula as the prime factorization it is given in the, it is arranged in the exponential form. See, in the 3 prime factorization, see here how to find out HCF. HCF always you have to take the product of the least power of the common prime factors. Least power of the common prime factors. Least power of the common prime factors. See, 2 it is not common for 12, 15 and 21. But 3 is common for all the prime factorization. Here the power of a 3 in the first case is 1, second case is in 15 is 1, also 21 it is 1. So for which least one it is also the 3 itself. Other than 3 no other prime factors are common. So for which HCF it is 3. Then after LCM, LCM is the highest power of prime factors used in all the prime factorization. Amongst all these prime factorization, which prime factors used maximally, that maximum prime factorization I have to write it there. See, 2 is used twice in the first, double in the second, no 2, third also no 2. So for which highest number of 2 used it is 2 square. So in the LCM I have written 2 square. Then after 3 used in the first factorization is once, second factorization once, third factorization once. So for which highest power it is also once. Then prime factorization, in the first prime factorization there is no 5, but in the second it is 1 5, but third one it is no 5. So for which highest number of 5 used it is once. Then after 7 used, first prime factorization no 7, second prime factorization no 7, but in the last prime factorization 7 has been used once. So for which highest number it is 7. So for which LCM is the product of the highest power of the prime factors used in all the prime factorization. So their product is 420. Just like question number I, also the second I question also can be done by you. And third I question also you can do in the same way. Otherwise, if you want, I am showing you the question number third I. See, 8, 9 and 25, the prime factorization of 8 is 2, 2, 2. Otherwise, one can write it as the 2 cube. 9 it is 3 square. And 25 it is 5 square. Just see, it is clearly seen that no prime factor it is common amongst these 3 prime factorization, as nothing is, no prime factor it is common. So for which HCF it is 1. Then after LCM is the product of the highest power of the prime factors used in all the prime factorization. See, first one it is 2q. So it means 2 is used highestly in 3 numbers in the first factorization. Then after no 2, then after also no 2. So for which 2 we have used it is for 3 times. So for which in the LCM I have to write it as 2 into 2 into 2. 3 also we found used in the prime factorization twice. So for which I wrote it as the 3 into 3. Also I got 5 used highestly is 2 number of times. So for which I wrote it as the 5 into 2 times. So the LCM equal to the product of the 3 2, product of the 2 3, and product of the 5 2 5. So for which total it is 1800. Then next question it is given. Then next question number 4 it is given. HCF of two numbers it is given 9 and LCM of two numbers it is asked. You know very well that HCF of a two number and LCM of a two number relation is the product of the HCF of a two number and the product of the LCM of a two number, it is also same as the product of the two number. Also we have done recently the question number 2. So for which you just have to see HCF of a two number, it is given that 9 it is given. But first step what it is written, just you have to see. LCM into HCF is equal to product of two numbers. Everyone knows because the HCF it is given. See everyone, HCF it is given 9 and the two numbers are given. One is 306, another one it is 657. So first I have to write the equation that the LCM into HCF is equal to product of a two number. LCM you do not know, but HCF you know it as the 9, which is equal to two numbers equal to 306 into 657. As it is asked to find out the LCM, so to get the LCM, HCF I have to transpose from the left side to right side. So I did the same way. LCM equal to product of a two number, that is 306 into 657 divided by HCF, which is equal to 306 into 657 divided by 9. That implies LCM is equal to 22,338. So this type of question it will come in many of the cases, that LCM HCF it will be given and it may be asked that how to find out the product of a two numbers. Also the LCM may be given, product of a two numbers may be given, and whenever it will be asked to find out the HCF, also you have to do in the same formula. Also many a times the question come LCM of two number given, HCF of a two number given, LCM HCF both are given, and also one of the number it is given. How to find out the another number? Also by using the same formula we just have to proceed and we can find out the answer. Okay, the formula is same, formula is the single formula, but but from the single formula different types of question it will come, but in the single way we have to solve. Okay, then after see the question number 5. Everyone see the question number 5. In the question number 5 it is given, check whether 6 to the power n can end with the digit 0 for any of the natural number n. It means 6 to the power n means value of n, how much I will take, such that 6 to the power n, how much the result I will get, always that result it will ends with the 0. 6 to the power 0 it is 1, 6 to the power 1 it is 6, 6 square equal to 36, 6 cube equal to 216. Then after beyond this I cannot calculate orally, but whenever I will do, it is known to each and everyone, always you will get either the unit digit it is 1, 6 to the power 0 it is 1, otherwise 6 always, it may be 6 to the power 1 6, then after 6 square 36, always you are getting that the order it will be this one. And another thing it is given, n it is given that the natural number, so it means 6 to the power any value you will take, actually really it will always be unit place, always it will be 6. But how to prove it with the proper formula? See here the total exercise we have to do it by using the prime factorization. Listen, to get the unit place, otherwise right side it is 0, it means one number it is 10, 10 means right side it is 0. Whenever I am choosing 10, always you have to just see 10, whenever you are prime factorizing, always you will get the factor it is 2 is there and 5 is there. 20 unit place is 0, always whenever you will do the prime factorization, always within the prime factorization 100% there is a 2 and 100% there is a 5. It may be 100 you may do the prime factorization, always at least 1 2 and 1 5 it will be there. 250, whatever the number you may consider, you can take at least any of the number whose unit place is 0, always you will find in its prime factorization, always the prime factors having at least 1 2 and 1 5, at least 1, then after it is extra, no problem, but at least 1 2 and 1 5 compulsorily should be there, such that the number unit place should be 0. So here it is given, the number it is 6 to the power n. Listen, 6 to the power n means whenever I will do the prime factorization of 6 to the power n, 6 I can factorize 6, it has 2 into 3 to the power n. It means, suppose I will open the bracket, listen, actually 6 to the power n means 6 to the power n, 6 I can factorize it as the, in place of 6 I can write it as the 2 into 3 to the power n. A into b whole to the power m, it means a to the power m into b to the power m. So which means 2 to the power n into 3 to the power n. So it means one thing it is clear, 2 to the power n and 3 to the power n. So it means many more 2 I will get, also many more 3 also I will get. So it means whenever I will do the prime factorization of 6 to the power n, there only many more 2 I will get, also many more 3 I will get. As I will not get any of the 5, at least one 5 it was required, but here I am not getting any 5, so for which 6 to the power n at any cost will not give any number whose unit digit it is your 0. Everyone clear? So first 6 to the power n means you have to factorize, and within the factorization only I am getting 2 to the power n and into 3 to the power n. So it means many more 2 I will get and many more 3 I will get, as there is not a single 5. So for which at any cost I cannot say for any value of the n, the 6 to the power n will give us the number whose unit digit it will be 0. This type of question also it will come. Okay. Next question. Next one of the question I will show to you. Question number 6, one of the bit I will show to you. Then after another I will leave for you. Explain why first expression it is 7 into 11 into 13 plus 13, it is a composite number. As we know that composite number can be factorized by the product of the prime factors according to our fundamental theorem of arithmetic. Remember, composite number can be expressed as the product of prime factors. And conversely also I am saying, if any of the expressions and if any of the if any of the expressions having only the prime factors, if there is the prime factorization, thereafter if there is the prime factorization of the number, so 100% whatever the number we will get, that number it is the composite number. Composite can be expressed as the prime factorization. If there is the prime factorization, it means whatever the number we will get, that number it will be the composite number. So to show the first expression it as the composite number, 100% the expression must be expressed it as the product of prime factors, such that we can say as it is expressed it is in the product of the prime factors, so for which I can say that the number it is the composite number. It means two things it is clear. If it is composite, it can be expressed as the product of the prime factors. Secondly, if it can be expressed as the product of a prime factors, then after it is the composite number. Okay, so here you have to show that the number can be expressed as the product of the prime factors. See, see, here it is given that 7 into 11 into 13 plus 13. So total two terms are there. One term having 7 into 11 into 13. Another term it is 13. Actually term means the the combination of the constant and a variable before the plus sign and after the plus sign. Otherwise before the minus sign and after the minus sign. Here before the plus and after the plus one terms are there. See, in both the terms one factor is common. That factor it is 13. 13, after taking the common factor it as the common, actually last term having 13 means 13 into 1. As whenever I am taking 13 it as the common from both the term, from the first term the non-common factors are 7 into 11, and second from the second term as 13 has gone, so here it is 1 left. Don't write by mistakenly 0 has left. Addition subtraction 0 left, but in the multiplication case it is left, it is the 1. Then after 13 and within the bracket it is 77 plus 1, which is equal to 78. Now the same expression can be expressed as 13 into 78. I want always to express it in the form of the prime factorization. 13 it is the prime, but 78 it is not the prime. So for which 78 once again I have done the prime factorization 13 into 6. I broke it in the form of 13 into 6. So for which the total expression it is equal to 13 into 13 into 6. Actually whatever the expression it was asked, the same expression I expressed in the form of 13 into 13 into 6. Also the 6 once again can be factorized it as 2 into 3. Here it was left at 6, but really I have to once again factorize the 6, which will be 2 into 3. So for which the total expression can be factorized it as 13 into 13 into 2 into 3. As we are getting one of the expression, it has the product of the prime factors. So 100% the factorization, the expression will give which number, 100% that number, it will be a composite number. Second question also in the same way. Second question, everyone, you just have to give your attention. In the second question also two terms are there. After the plus, first term it is 5, and before the plus the terms are 7 6 into 5 into 4 into 3 into 2 into 1. Okay, and both the term having the common factor, it is 5. After taking 5, it is the common, just like the previous one. We are getting 7 into 6 into 4 into 3 into 2 into 1, and the last one it is plus 1. As 5 has gone non-common, it is 1. So here we are getting it as the 5 into 109. As 5 it is a prime number and 1009 it is also a prime number. You just have to take it as the prime number, otherwise one can say it easily 5 is a factor and 1009 is a factor, as the number having two factor other than 1 and the number itself. So for which 100% is the number, it is the composite number. Otherwise one can say, as the expression we can express it as the product of the factors 5 into 109, then after we can call it as the number, what the expression it will give which number, that number 100% it will be a composite number. Otherwise you can say it easily directly, the result we are getting 5 into 109, it means 5 can divide that number, also 1009 can divide that number, the number which will be divisible by the number itself and other than 1. So 100% the number it will be a composite number. As the number it will be divisible by both 5 and 1009, 100% the number it is a composite number. Ready? Then after question number 7, see the question number 7. Listen, before doing the question number 7, once again I am asking you something. Listen, suppose me and another students, suppose me and my favorite students is, suppose you all are my favorite, but I am choosing one who can run. I am physically I will put who is the who is having the better fitness. So I am choosing Tanmay. Suppose me and Tanmay both are running in around a track, circular track is there, and I will take 2 minutes to cover a track, and Tanmay will take 3 minutes to take a track. Take the total round around the circular track. Okay, so I am taking 2 minutes, Tanmay will take 3 minutes. So for one round I will take 2 minutes, second 4, next one 6. Tanmay will take first round 3, then after 6, then after 9, then after 12, then after 15. Can you just say me what is the minimum time at which once again me and Tanmay we will both meet with each other? Just see, my round is 2, then after 4, then after 6, then after 8, then after 10. But the Tanmay time span it is 3, then after 6, then after 9, then after 12, then after 15. It is clearly seen that 6 is the minimum time at which I will be at there in the origin. Also Tanmay will be there at the origin. So for which here it is the little number it was given, for which you could capable to say it easily, but whenever the numbers are large number it will be given. Instead of calculating just like I have calculated, you just have to find out the LCM of the two numbers. So whenever it will be asked that to find out the minimum distance at which both of them once again will meet with each other, always you have to find out the LCM. LCM means least, minimum word, otherwise least word. Whenever normally it will come, you just have to think about that one. It is the question is asking about our LCM. So here the question asked, there is a circular path around a sports field. Sonia takes 18 minutes. Sonia takes 18 minutes to drive one round around the field, where Ravi takes 12 minutes for the same. Ravi takes 12 minutes and Sonia takes 18 minutes to cover the field. Suppose they both starts at the same point and at the same time and go in the same direction. Okay, so both of Ravi and then after Sonia started running from the origin point, and whenever they will start covering the distance, the question it is given how many minutes where the question has gone and go, after how many minutes they will they meet once again at the starting point? Once again they will meet at the starting point when? So your answering is, you just have to find out the LCM. Everyone knows how to find out the LCM, but here to get the LCM always you have to follow the fundamental theorem of arithmetic. So in the same way here it is given that 36, so for which one can say that after 36 minutes once again we will meet, both of them will meet with one another. Okay, I hope the video must be useful for you. Many thanks for watching the video. You just have to keep continuing the exercise 1.2. Then after once again in the exercise 1.3 theory discussion we will do it in the online class. Okay, thank you, have a great day.